Okay, so we're entering week 7. We're going to be reading chapters 4, 5, and 6 in Hattie and some additional readings. And I want to offer an additional perspective, a complementary perspective, a perspective that expands on and certainly does not detract from the way that Hattie has explained things. They both are valid ways for us to envision the learning process. I like to use this one because it links with some literature I use in a later course, Psych 749, to help school psychologists develop skills for database decision making, academic and behavioral problem solving, and intervention, selection, design, and implementation. So I'm going to take just a few minutes to talk to you about a process put in place or described by Haring and Eaton in 1978. Haring and Eaton told us that we needed a framework in which we could understand and build supports for complex learning. They recognized that we often attended to the sequence of skills that supported larger academic skills. For example, addition before multiplication, the alphabetic principle before phonics, but they also stated that we sometimes forget to attend to the framework within which to teach those skills so that they become durable and functional, which is where we get the social validity of our instruction. It has meaningful utility in the world. Now, we've developed and adopted a learning definition in our course that described learning as a change in actual or potential behavioral capacity that was not due to some physiological or transitory cause. Haring and Eaton give us another perspective that we might either adopt instead of or probably simply adopt along with this previous definition, and that it places learning in a context. It says that the ability to perform new skills in progressively more complex situations is what we should consider learning to be. So they provide us a context beyond that it simply changes us, but that it makes it possible to do more complex tasks as we change. Thinking about developmental psychologists and constructivist teachers, I immediately come to think of Piaget and Vygotsky, and in Reed and Hresco's paper, we see these concepts displayed. Essentially, the most important thing we do when we teach is to begin to teach from where the learner already possesses some skills. That fits nicely with Piaget, assimilation and accommodation. It also fits nicely with Vygotsky, zone of proximal development. We begin just beyond where the student is unable to perform the task by themselves, and we scaffold them. So learning is a process of elaborating on what a child already knows could be added to our definition. Haring and Eaton talked to us about the fact that no skill is learned instantly. Now, we did see some theories that talked about one-trial learning, essentially instant learning, but those aren't really deep skills. Those are types of things where we avoid something because of an immediate expectation. So, while we might say no skill is learned instantly could be questioned, I wouldn't argue it too much. Haring and Eaton offer us 4 levels of performance that comprise the learning hierarchy as they describe it in their model. Their 4 levels are acquisition, fluency, generalization, adaptation, and application. Goodness. Now, if you look in your text in your Hattie book on page 97, you see something very similar there. You see a first phase where the learner is a novice, and the next phase where we acquire some capability, and in a final phase, we become more automated. Okay, so these 3 phases of how we learn described by Hattie really fit into the first couple of phases of Haring and Eaton. You keep looking on page 97 and I'll show you why. This first phase, acquisition, is about what's going on from the first appearance of a desired skill until that point in time that the person can reasonably accurately perform that skill. When we first begin to perform a skill, we make lots and lots of errors. So the emphasis at acquisition, at acquiring that skill, is on becoming accurate at doing it. Our goal is to transition from making lots of errors to making far fewer errors. To do that, teachers can use strategies like demonstration, where we actively perform a skill for the student. We read a passage out loud to them. We solve a math problem on the board. We can use models, giving them examples of readings or leaving solved problems on the board. We can offer cues. We can prompt them. This is very closely related to zone or proximal development. We give them just enough extra help to get them over the top. Or we can have them drill. Drill is simple practice. This is Thorndike, repetition. Okay? So teaching strategies at that first level of learning a new task, at the acquisition level, are to demonstrate, to model, to offer cues, and to drill. And the point here is to reduce the number of errors made as they perform this task they've never done before. Now, acquisition doesn't happen at one point in life and all of a sudden we're doing something different. Every time we approach a new skill, we approach that skill from the acquisition perspective. The first time I try to add single-digit numbers without regrouping, I'm acquiring the skill to do that. The first time I try to add single-digit numbers with regrouping, I'm acquiring the skill to do that. I make many errors, but I work to reduce those errors, to acquire that skill. Fluency building is the next level discussed in Haring and Eaton. Moving beyond doing something accurately to being fluent at it allows us to become proficient so that we can use it in meaningful ways. I think of this as saying if a child can read a word or read several words in isolation but cannot read the words together to make meaning, then we have a problem. If a child can do basic math calculations but cannot do it rapidly enough to solve the problem before the class moves on, then we have a problem. So at the level of fluency building, the way we make an acquired skill more meaningful is we develop speed. We become able to use it quickly enough to make it practical. So our emphasis in teaching and our emphasis in understanding whether we've achieved this level of learning is to pay attention to speed. When we did our CBM, we did CBMR, and we looked at words read correctly per minute. Words read correctly by themselves, no time limit, would be a measure of acquisition, perhaps. But words read correctly per minute, I've introduced the emphasis on speed. It's now a ratio of performance to time. That's a measure of fluency. Now, the way we teach fluency skills are repeated novel drills. Practice again. This is again related to our early associationist. You do it often enough, you get better at it. Practice makes perfect. And reinforcement. We guide, we reinforce, we encourage the demonstration of those skills in order to make it worth the work, because repeated novel drills is indeed work, and we have to make work satisfying. Okay? If we put this back in the reading model, moving beyond accurate decoding to being fluent with decoding would therefore allow us to begin to read for meaning. When we talk about practicing here, when we talk about repeated novel drills, I'm really talking about learning responses that I can use with other learned responses in unique situations. So we're going to step up to that now and talk about the next level. Once I have acquired a skill, once, in other words, I make few errors, then I have become fluent. I not only make few errors, but I can do it relatively quickly, so it's useful. Now I go into a phase of learning which Haring and Eaton describe as generalization. And generalization is about being able to perform a skill in response to a new stimuli, similar to the one used during training. Okay, so now our emphasis is on novel stimuli. Think about this. If you are the student or if you're teaching a student and you're taught to do it in a specific way, every time you do it that way, you recognize it. You know what to do. But what if the skill that has to be performed is the same skill, but the stimuli is different? Probably the clearest element of being able to express this would be to think about the way we often express mathematical equations. If I was to write 2 plus 2 equals 4 horizontally across the center of this slide, you would recognize that immediately as an addition problem, and you would add 2 and 2 for 4. If I was to write 2 plus 2 vertically with 4 below the line, you would recognize that as an addition problem, and you would solve it quickly. But to students who are learning a skill, this is a generalization issue. Being able to generalize from the task of adding these two digits written horizontally versus written vertically is about having a novel stimuli, having it presented in a way they haven't had to do it before, and being able to recognize that that's still the same task and they have to do this specific behavior for that task. Discrimination and differentiation training are rule-based models, and they facilitate this generalization. Discrimination training is learning to respond in the presence of a specific stimuli while not responding in the presence of another stimuli. Back to our math example, if I gave a child a math worksheet that had addition and multiplication task on it, I need them to respond in a specific way to all of the addition task and in a specific way to all of the multiplication task. And we often see this early on in young students where they start adding and they just keep adding and they add right through the multiplication task, right? Most of us have seen that happen. That's a failure to discriminate, and it's a failure to generalize skills. Differentiation training is about reinforcing responses while we modify one essential element. So this is about having a student evaluated as this is such and such or is not such and such because of a modification. And that would go back to the issue of writing horizontally or vertically in math formulas. Okay? So we have to acquire the skill. We have to be able to do it relatively accurately. We have to have fluency at the skill. We have to be able to do it at a rate that it becomes practical, that it's actually useful. We have to be able to generalize, which involves both being able to discriminate when to do one task from another and when to recognize that the task is the same task, just presented to me in a different way. And then finally, we achieve their fourth level in Haring and Eaton, which is about adaptation and application. In adapting or modifying a behavior, we meet the current situational needs. So now we not only have the ability to do it quickly and to recognize when the rules are changing and I should do one thing or the other or continue to do the same thing, but now I'm able to meet my situational needs. So now the student is introducing contextual cues. The emphasis here is on adaptive responses. It's on selecting the right skill from all of the skills I possess for the present situation. We teach this by teaching problem solving and by having simulation games and through modeling. Okay? Modeling again because it gives us these examples. So let me give you just a couple of really simple examples of adaptation. In some situations, it might be appropriate to say, please. In other situations, it might be appropriate to say, I would appreciate it if. Being able to make a determination about which of these responses in my repertoire are appropriate for that situation is important. Saying thank you and saying I am grateful are different examples of context-specific responses. So once I know how to use a skill, I can do it quickly, I can recognize the rules around that skill, then I have to be able to put that skill into a context and put it to work, and that's adaptation and application. So in our text, in our Hattie text, we have acquisition and fluency represented, and perhaps to some degree Hattie's proficient phase would begin to move to the last two phases of Haring Eaton, but it's really about to me, it's about the last phase of fluency. So I want you to have both of these models because I think that they are complementary to each other. Personally, I believe that the model used by Haring and Eaton is more complete. But I also have a bias there because I have a way to adapt and apply that in additional research. If you're interested in that additional research, I can put a copy of it in the course library. I normally teach that in Psych 749, which is one of my fall courses. But it's about using brief experimental analysis, which is a very efficient way to identify with high probability what will work for a given problem. As a part of a database decision-making model, this is a problem-solving model of empirical troubleshooting that we use for both academic and behavioral problems. The article was written by Daly, Witt, Martins, and Duell in 1997. It's called A Model for Conducting Functional Assessment of Academic Performance Problems. And it works directly with the Haring and Eaton model because it posits 5 reasons why students frequently are unsuccessful. The first one is that the student doesn't want to do the task. The next one is the student hasn't had to do the task, or the next several of them are related to Haring and Eaton in that the student has not had to do the task that way, which is a generalization problem. The student hasn't had enough help doing the task, which is a acquisition problem, and so on and so forth. So this is a great supplementary read. So here are the references for the discussion I just shared with you, and I hope that you'll take this into consideration as you read Hattie this week, and maybe make it a part of our discussion in the forums. Thank you.